Yeah. Okay, so we are going to put what? 2.7.
5 under oxygen.
Okay.
Because it says of oxygen.
2.75 moles.
And then you're looking for Hg. So under that, under Hg, you're going to put mole with the question mark.
Okay.
Then, so you have, wait, simmer, just hold on. So you have 2 hydrogen. Well, Hg. 2.75 moles of O2. There you go. And then times, 2 Hg. What's the moles of, And then you put 1 mole of O2.
And now we're ready to solve. Thank you for that setup. And we should get 5.5 moles. Now, I am going to start holding you to this. How many significant figures was in our question? 2.75. How many signifigs? 3. So our answer has to have, so 5.50 moles Hg. Okay, so you always go back to your question and you get your least amount of sig figs in your question. So if this were to say the test and it said on the test, make sure you have the correct number of sig figs. Sig figs is going to be part of your points. It might be 1 point out of 10 or whatever. Okay, so our next step is to find how many moles of nitrogen monoxide will be needed for 0.75 moles of ammonia. So which one is nitrogen monoxide? The 6NO. And which one is ammonia?
4NH3.
4NH3. So we've got our little start there. Everybody else? Doesn't matter. So we start with what we know. 0.75 moles. NH3. 6 moles of NO on top. 4 moles of NH3 on bottom. We are in the unit we need to be, so we are ready to solve. So it's 0.75 times 6
is
4.5. 4.5 divided by 4. 1 point, we need 2 sig figs. 1.1. You said 1.12, was it?
It was 1.125.
25. All right, so now I need 2 significant figures, 2, 7, and 5. Those are the only ones that matter. So that means my answer has to be taken to 1.1. And the unit is moles NH. Oh. NO. NO, sorry. 6 times 0.75, yes. All right, so that's the thing is you need to be putting these in the calculator as we're doing it so that if you have a mistake, we can go back and we can look on the calculator and see where you made your mistake. Okay, any questions on that? All right, so let's go on to our next step. All right, so what we're going to do is called mole to mass conversions, or it is also mass to mole conversion. So you will be asked to go from either grams to moles or from moles to grams. That's what you are required to do for today and tonight's homework. So when I say grams, what should you think of? The mass, okay? So what we're going to do is our molar mass, which is grams per mole, is our conversion factor, our second conversion factor. So what we're going to use, mole ratio, always have to use the mole ratio, and now the molar mass. Now, since this is a conversion factor, it can be grams over 1 mole, or it can be 1 mole over the grams, depending on what you need. So the very first question here, we have 6 carbon dioxides and 6 water. So this is photosynthesis, and we get a 1 mole of glucose and 6 moles of oxygen. So my question says if you have 2.38 moles of carbon dioxide, so I'm just going to go ahead and write that under what I have, 2.38 moles. How many grams of glucose can be made? Everybody else, all this stuff, we can ignore. So the very first thing is I'm going to identify what are we going from what to what? We're going from moles to grams. So anytime you go from moles to grams, what you need to do is your first conversion factor will be your mole ratio. And it's always going to be unknown over known. Your next conversion factor will be the molar mass of your unknown. And it's always going to be grams over 1 mole when we go that way. So let's go ahead and start our problem. So the problem says to change the given to moles. Well, we're already in moles, so I'm just going to go ahead and write that here, 2.38 moles of carbon dioxide. Next step is you need the mole ratio of your unknown over your known. So my unknown coefficient is glucose, and it is 1 mole. And we're going to put that over our known coefficient, which is carbon dioxide, and it is 6 moles. So if we are doing our conversions right, we have moles of CO2 go away. And now what's the next step? Because now we need to find the molar mass of our unknown. So we go all the way up to sugar. We go up here, and we have carbon, which is a mass of 12.01, and there are 6 of them. We have hydrogen, which is 1.01, and there is 12 of them. And then we have oxygen at 16, and there are 6 of them. So when we add all those together, we should get, if we did it right, 180.18 grams per mole. Okay, so there's a little added step. You've got to go find the molar mass. Sometimes it's given to you, and it'll say the molar mass of whatever is 180.18. So now we'll put it into the problem where what goes on top, what goes on bottom. Well, no, well, I know we're to the unknown, but we're using the molar mass of our unknown. So grams has to go on top, so 180.18 grams of glucose. And that is always over 1 mole. So don't try and put a different number here. If there's a 6 in front of glucose, don't try to put that 6 there, okay? It's always in 1 mole. The only time moles should have a number in front of it is during the mole ratio. So now we have, what? 2.38 times 1. Somebody should be putting these in the calculator. 0.18 over 6 times 1. If you don't have a calculator, you need to go get one. $428.8. 82. Okay, so now we go back to the answer or the question, and we see that we have 3 significant figures. So my answer in 3 sig figs is 429 grams of C6H12O6.
What if it asks for 2? Or is that like
Huh?
I said, what if it asks for like 2? Or is that
Okay, well, to what?
like a 3?
Hold on. Wait. Let me get Caden's question first. Okay, yes.
For like 3 whole numbers, would it ever ask for 2 sequence?
It might. If that would have said 2.3, then my answer would be 430.
Oh, okay.
You're supposed to divide it by 6, right?
Yes. Oh, okay.
It's like 71.447. Yeah, it's like
So we have, 71.47. And if we take to 3 sig figs, then it should be 71.5 grams of glucose. Okay? So let's work another one. Everybody good with this while I go to the next slide? Okay. So now this one says how many grams of KClO3 are required to produce 9 moles of O2. So I start with what I know and what I don't know. So I am going to grams of ClO3, and we have 9 moles of O2.
Wait, KCl?
How many grams of KClO3? Yes. To produce 9 moles of O2. Now, okay, so what's our first step? We are in moles. So our first step is we're just going to go ahead and write down 9 moles of O2. We're already in moles, so we don't need to convert it. So now that we're in moles, we can go and we go to the mole ratio. And what is that ratio? What's on top? Unknown. And that number in front of it is 2. And on bottom is our given, and that is 3. All right, so now that we're in moles of KClO3, we can take these to grams of KClO3 by finding the molar mass of KClO3. So K is 39.10. 39.10. Cl is 35.5. And oxygen is 16 times 3 for 48. So what do we get for the molar mass? No, we do not care about the coefficient when we're looking at molar mass. We need it for 1 mole. What? 122.6. Thank you. 122.6 grams per mole. That's the molar mass of KClO3. So we have 1 mole of KClO3 up here, moles of KClO3, so that now goes down here. And when we're talking about molar mass, it's always in 1 mole. And on top is the grams, 122.6 grams. So now we multiply everything on top. So 9 times 2 times 122.6. And divide that by 3 times 1. 700. So 735.6. How many sig figs are in our question is 9.00. So that means we need 3 sig figs. So 736 grams of KClO3. Any questions on that? Yes.
So, like, how is this different from what we did yesterday?
We're just adding one more step. So,
Not added yet?
yeah, we've added it. This was a step from yesterday. This is the net added step.
Oh, okay.
Okay. Any other questions? So now we're going to start with grams. I'm going to give you grams, and we're going to take that to moles. Everybody good? Okay. So now we have the same formula, but this time we're starting out in grams. So you are given, or you get 45.67 grams of oxygen. And it wants to know, when we got that, how many moles of KCl was produced. So very first thing, start with what you know. So this time we are going to go from grams to moles. So the first thing we need to do is we need to change those grams, 45.67 grams of oxygen, into moles. So the first thing we're going to do when we're doing this is our first step is going to be the molar mass of our known. And this time it's going to be 1 mole over the grams. So we have grams of O2. We need to get rid of grams of O2. So we need the molar mass of O2. 16, and there are 2 of them. So 32 grams of O2, and that's always in 1 mole. So there's my first step. We have used our molar mass known. And the next thing what we need to do is we are now in moles of our known, and we need to get to moles of our unknown. So now we use the mole ratio. So we need the ratio of our known on bottom. So what's the coefficient in front of oxygen? 3 moles of O2, and on top we need 2 moles of KCl. And now we're ready to multiply 45.67 times 1 times 2 over 32 times 3. And what do we get? Oops. 2.854. And if we want to take that to the correct sig figs, then that means we need to have, oh, that is. So 2.854, and our unit is moles of what? KCl. Tomorrow, we'll take it one step further, and we're going to take our moles of KCl and go to grams to KCl. So we're going to use the molar mass of both of them. And those are always easy. I think the more steps is easier because I kind of have it broken up into what's going where. This one you've got to decide, are you using mole ratio first or molar mass? When we do tomorrow, we always know we're using molar mass first. Okay, so go to your homework. So taking a look at your homework, I do want to say that, one, today I posted the answers, just the answers only, to 1 through 7, or 1 through 6. And then in another post on homeroom, I posted the answers for 7 through 18. So what you're going to do today, so your assignment for tonight are problems 7, 9, 10, 14, 17, and 18. Everything else will be homework for tomorrow. So let's look at question number 7 together. Question 7 says, molar mass. The mass of 1 mole of a substance is measured in what? What is our mass of our substance measured in? Grams. And this is called what? What type? Blank mass. Molar mass. And we are going to use this as what to get from moles to grams of a substance? Conversion factor. Good. So I'm going to work number 10 with you guys because I think it's having to come up with the problem. So number 10 says zinc metal can be obtained from zinc oxide. So I know that my product is going to be zinc. And I know that my reactant is zinc oxide. By reacting the oxide with the element carbon. So we're going to react this with carbon. So carbon is going to react and we're going to get zinc and carbon dioxide as a product. What type of reaction is this? Single replacement. Thank you. So then we're going to balance it 2, 2. And then our question says, a student is told to use 5 moles of zinc oxide. And we want to know how many grams of zinc can they get? So what's our very first step? Write what we know. And then I heard y'all say unknown over known. So the ratio of our unknown, so 2 moles of zinc for every 2 moles of zinc oxide. So now we are in zinc and we need to get to grams of zinc. So we need the molar mass of zinc. So 65.39 grams of zinc And that's always in 1 mole. So 65.39, 326 point what? 95. So we need to have how many sig figs in our answer? We need 3 sig figs in our answer.
Yeah.
Why?
Where you need
Wait, we're not using that problem.
It's just number 10.
It's number 10 in our homework.
327.
So 327 to the correct sig figs. 327 grams of zinc. Thank you. Questions. So on homeroom is a picture of the answer. So when you're working these, go to homeroom and see if you're coming up with the right answer. Any questions? And there was a second part to 7. Remember, it said what's the molar mass of H2O2 and H2O. So that is it. Tomorrow we will take it a step further.